how did you measure the velocity of the jet?
We have a few types for laminar and for turbulent flow. It depends on the velocity profile. We have different formulas, and I can show you the slides, последний slide.
Okay, that's fine. For the reporter, do you think the droplet size is important?
Yes, it is very important.
And does it want to be? And
Like if the droplet size, this is the most important parameter for aerosol.
okay, yeah. How qualitatively for the opponent, what does the Reynolds number and the Weber number represent?
The Reynolds number, yeah, depends on the velocity, but also
What does it represent?
it represents the properties of liquid, but also the characteristics of the system.
How did you determine for the reporter the probability distribution curve for the graph you have, and why was it?
I don't understand what you mean.
How did you determine the probability distribution of your curve of the droplet size?
It's from the photograph.
Why was it the curve you fitted? Why was that particular curve fitted?
I don't understand the question. Can you be a bit louder?
Does the opponent
Does
want to agree with the distribution that was fitted?
It was fitted. Yeah, it was fitted in our graph. It's not
What was the basis of? Was there a theoretical prediction for that?
No, it's not theoretical prediction.
For the opposition, how does temperature affect? How do you think that temperature affects?
Yes, right. The temperatures, with the increase in temperature decreases the viscosity, which results in smaller droplets.
Thank you very much. Now we have time for you and team to check for the main presentations.
So I'll be reviewing problem number 2 aerosol reporter for team data. So I'll go through overall presentation of the reporter and opponent, presentation of the reporter, opponent, and then discussion result. So the problem statement asks us to investigate when water flows through a small aperture, an aerosol may be formed, and to investigate when the parameters that determine whether an aerosol is formed rather than jet, for example. So it's asking us to determine some thresholds, some variables that do affect aerosol formation. And then what are the properties of this aerosol? And so neither the opponent or the reviewer overall give an explanation of aerosol formation fully in an intuitive physical understanding of it. And essentially, it's basically when it's the fluid breakup which occur as a result of turbulent interactions at orifices, at apertures, which is clearly mentioned in the problem statement as well. Now, there's no threshold investigated by the reporter for when an aerosol is formed, and there isn't a fully numerically theoretical model that they can use to explain whether it was formed or not. And and what are the properties that affect the aerosol formation. So the strength of the report overall, there was good qualitative explanation of how, with images and diagrams at least, how the aerosol was being formed in their experimentation. They lay out assumptions with the flow they have and optical and electrical properties. Areas for improvement included there was minimal explanation of what causes an aerosol. In general, determination of data was very unclear. There was unclear determination of jet velocity, droplet size, and it seemed really inaccurate. The setup was outside in the image they had. It was uncontrolled wind, atmospheric, that could affect at random errors. They were lacking error analysis on the results. They had no error bars on some of their graphs. Theoretical fits were not expected. There were no theoretical fits for some graphs. And superficial mathematical relationships were mentioned about Reynolds and Weber's numbers, but neither was fully discussed. The problem was not fulfilled in our opinion completely, and the limitations of aerosol formation were not discussed. For the opponent, they did identify the lack of setup precision, which was really good. They made it clear that there had been no systematic investigation into the conditions required for an aerosol to form. And droplet size distribution and angle results discrepancies were discussed, and the lacking theory was mentioned as well. For opponent improvements, the reporter did lay out secondary atomization, where they mentioned which is essentially the interactions of air after it has exited. So with air drag, for example, affecting it, and we do agree with the reporter in that sense and disagree with the opponent. There was no presentation of any physics principles to refute the reporter, however, and that was also they didn't even put their own physics. With regards to this discussion, the opposition mentions the investigation into orifices, and the reporter agrees that shape could be different. We do agree with the opposition and the reporter as well in this case that there could have been a further investigation, and the opposition, but however the opposition did not really present their own input with the investigation into orifices, so it was just kind of mentioned there. And we do not agree with the opposition in that sense. The shape of the orifice is going to affect the turbulent interactions that occur, and hence the shape, for example, of the aerosol or the angle as well. For droplet size and theoretical distributions that opposition mentioned, of course, we agree with the opposition that there was, the reporter mentioned that they assumed the error was insignificant, which we do not agree with. We can clearly see they can't, for example, measure 10 to the negative 7 meters of aerosols, which they didn't show that they measured that. And so how do they determine the average size of aerosol droplet sizes without error? Overall, the discussion, there was no mention of aperture size, which is in the problem statement. Effective changing problem statement was not mentioned. Reporter's minimal error analysis, reporter's errors and does not include them, and the opposition agrees that that's right. Overall, the reporter did not fulfill the problem statement.
Thank you very much.
First, I need to say that the pressure was constant because we worked at speeds, we worked at the small speed, and here you can see the difference in the speed. And we worked and we make reports immediately after the aerosol appears, so we will have something like this. Also, we understand that in the discussion we will talk about real important terms, but the physics wasn't improved. So first we talked about the light. We don't investigate other apertures because we need to find a way how to control our situation. So if we will use only geometrical differences, we can control it. So the second question was the method of measurement of the droplet size, and we understand that the accuracy of this measurement was very big, and we can neglect the errors which we have. Then we understand that all the drops were not like a sphere, but we have an assumption that in the photograph we can find out it's clearly from the picture. So also the question about the angular distribution, and the main part of this angular distribution is that we understand why it happens, and I can explain this for the jury if they want. And it is because the droplets can rotate and divided on the smaller ones, and therefore we will consider this situation. So we will see that, for example, here we can see the droplets which rotate, that it divides on the two ones, then it divides on the smaller ones, and so. Therefore, in the middle we will see the biggest one, and in in this one we can see the smallest one because the droplets divide all the time because they have perturbations in itself. So thank you for your attention, and I'm ready to answer the questions.
Thank you very much. Could you start? What is the
One just double check if I understood it correctly. You have glass on which you projected droplets,
No.
or
No.
what was the surface?
We haven't a surface at all. We make the photo with a small depth of field. So, for example, we haven't got something where we use it. We have like a photograph of the aerosol and choose the small part of the particles because we
Just
have,
a little small for glass.
Yeah.
Okay.
it was only the focus.
So,
Okay, Daniel, that's first, sorry.
Okay, now, I would like you to open the slide number 29. Just equally clarifying question. You have mentioned the mean scattering here, and you suppose that it is independent on the wavelength, so you say that it is a mean scattering. Am I correct here?
Yeah.
Okay, then.
Just very quickly, it's not absorbing, it's centering, right?
Yeah.
Okay.
So, yes,
Sorry, Jakob? now?
Yeah, and so could you go to the graph where you had droplet size, this distribution plot? So two questions. First of all, the size uncertainty of the droplets, how did you determine that?
It
Because we
was.
see error bars here.
The errors was only from the picture, so we understand that we have the error was a pixel from the photograph, and we have found the value of the error.
Yeah, and second part of my question is, so the distribution you have drawn here, is this a normal distribution?
In the literature, we saw that it was a normal distribution, and we can find it here, but it's like goes to.
Okay.
This is the direction.
The question was, is this shape the normal
Yeah.
distribution? That
Yes.
is-
Yeah,
This
this is
is-
the shape of normal
This
distribution.
shape is the ocean.
Yeah.
Okay. Ivana?
At one point you were discussing the size distribution on the above or and below the major axis. Okay, so question for the viewer, opponent, and again reporter. So are the droplets above and below the same size?
So above and below what side?
It depends on.
Like, so you have the
No,
axis and the major
In
jet,
neglecting gravitational.
and they said that distribution was from above until below. Is the droplets above and below
neglecting
the same?
gravitational effects.
Same
neglecting-
size.
They would be different sizes, but it would
Okay.
be randomly distributed, not how the reporter said.
They would be randomly distributed. Okay?
Well, they are for circle, of course, for example, circular nozzles, they are same size.
And reporter.
They will connect to each other if you fall down. So the droplets here will be bigger than the droplets here.
Thank you.
It will talk about that.
Thank you.
Sven?
So just again to make it clear to the reporter, have you performed a single parameter or a number of parameters to determine whether you have a jet or an aerosol? Just, you have mentioned Weber number and Reynolds number. Have you performed like a parameter that I could look for to determine which
We talk about a system of parameters because the system of parameters are
Okay, have you determined that?
What?
Have you determined the system of parameters
Yeah.
and the critical values for them to?
No, therefore it is a system of parameters, so we can't find the critical. We can find the critical if the another parameters were fixed, and we can find the critical value as the other parameters were fixed. So we can do it, and it was did, but it's not in this presentation.
Okay.
Yeah, right. You spoke right. The slide up. I want to see as well. Yeah, please stay on the slide. Yes, the Weber number slide that you just had. The Weber number. Yes, this one. So on the x-axis we have the Weber number.
Yeah.
Can you just shortly explain why is the droplet size going down with increasing Weber number?
So if we write down this one, we can use this formula and
Yeah, but just short, like pure physics here.
Yeah,
Why is
from
there?
using using a simple mathematical transformations, we will see that it will be linear from this formula.
Okay.
So if we write down this one.
Thank you.
That's laminar flow breaking into droplets and
Yeah.
flight.
Laminar.
Laminar flow.
It's because we have the, for example, we have small perturbations. Sorry, not like this. It will have small perturbations and therefore.
Are there perturbations in the laminar flow?
What? For example, it is not. It's a random process. Therefore, we understand that. For example, it's the wind goes here or something like this, and it gets it.
Thank you. will start with the grade 4 reporter. I will read from this side, and mine will be the last one. Is that fine?
Please from your.
Okay, no problem. Of course, no problem. Start with me then, and that's 5, 5, 3, 6, and 5 for the opponent. It's 5, 5, 5, 6, and 5. And for the viewer, it's 9, 7, 6, 5, and 6. Okay. We have different opinions represented, but that's always good, right? Because everybody has different perspective and different priorities. And we will start with a report, I think.
With the lowest.
Yeah.
For the lowest grade here, first of all, I really suppose that that's not the best problem you could choose in this year, but overly coming through the scoring sheet, you have not performed the theory and comparison of theory with the experiment at all because it's really tough to write something here, but it could be done. I mean, you could calculate the critical length of the jet when it's breaking. You could calculate the distributions of which was mentioned by both opponent and the reviewer, but there was no theory here for me, so you've lost all the scores in these two columns. Then, considering the explanation of the phenomena, I here agree with the reviewers that you haven't presented the basics physics, why the jet is breaking on the drops. I mean, you have said the related stability like in a row, in a few seconds, but that's not enough for me from the point of explanation. And the task fulfillment is the main problem here, because you have not presented this criteria, how you determine whether it's an aerosol or not, and you have not investigated the parameters of aerosol except of the average diameter, which was investigated only on the one slice, not in the whole like aerosol you got. And as well, as I got from the discussion, you have cut out the edged particles, which were like too small for you to analyze with the camera, but it influenced your average diameter. Definitely, I mean, they're too small, but they're small, so it decreases the average value. Unfortunately, that's a huge inaccuracy here. So that's why you lost a lot of points in the report section, and the other was pretty.
Thank you, but we also had 6.
So, first of all, hands down for the courage to take on this task, this problem. So, I amazing. What I was really blown up by your optical and electrical properties that I completely missed, because it's like the question is what are the properties of the aerosol, and I would think about optical and electrical beside just physical, mechanical, call it whatever you want. So for that, I was really astonished. The problem was you speak too fast. And we couldn't I couldn't pick up the all of that. That is one minus. The second thing that decreased your initial rate impression. I don't know, maybe because I'm the highest mark, I can just say the positive things. It's also, but yeah, the bad things were all really sad.
Can I add a bit? So I would like to really, I appreciate the enormous amount of mental effort, because you presented a lot of things carried out, and I really like that. And I agree that this is a terribly hard problem, meaning that I find it very much acceptable that we go with a kind of experimental approach, but more focused on dimensional analysis and things like that. The problem, however, is that it was very hard to see a connection between, for example, how the Weber number, how the Reynolds number then connects back to the experiment you have done. So it was hard for me to, even if we go with just some kind of dimensional analysis thing, I felt that then even that I couldn't really see how all your experiments kind of fitted together into the picture. So it was just like a huge V wave, which I couldn't really get an understanding over. And also, I had to subtract for the distribution. I mean, unless like my eyesight is wrong, that was a clear skewed distribution, so it cannot be a normal distribution. So I don't understand then how that could come about. But otherwise, I was very impressed on the experimental side.
I would like to support this because I agree with this part that it was difficult maybe for us to appreciate everything what you've done because it just wasn't too clear. And the proof of it is that we had so many questions at the end. There's also like minus for the opponent, of course, but there were so many topics we were eager to ask further. So maybe if your slides would be organized in a different way, then it would be clearer for us. We would not need to think about those things as much because, yeah, I feel like there may have been way more work than actually was communicated. But yeah, it's still a good number. And for the opponent, we were quite consistent with 5s and 1-6. So I already mentioned that, yeah, this is a huge minus that there were so many interesting work done which we would like to hear more about, like how was it clarified from the slides which we didn't understand, which did not happen that much. I think
We also had on the 5. So, I mean, the role of the opponent kind of varies depending on the report. So if we have a report that's kind of empty, I am very much okay with a report where the opponent saying, oh, could you have tried this, or could you have tried this, or could you have tried this? Absolutely. But when you have a report that is one of the most packed reports I have seen, I mean, among my years here, I do expect the opponent to try to help me as a viewer kind of clarify, okay, which things in this whole report was kind of okay, and which things are not okay. And I felt you did some of this, and that I gave score for it, but you also felt too much had, oh, I want to talk about temperature, I want to talk about velocity distribution. So you had, it more or less felt that you wanted to talk about the things that you yourself had been interested in rather than the things that we actually saw. So if you, for future reviews, please try to more focus on what's in the presentation. I think it's going to be higher.
To have a smoother transition, I got this impression that this is exactly what review were done. That's what I gave 9 points because it's not just that you explained clearly what was happening. You also said what was missing, and not just saying it was missing, but you were saying what do you think about that? What is your opinion, and how would you do it? It was a lot of information in your slide, and I couldn't think of anything important missing. It was very clear. Also, I appreciated the questions which were also very clear, very important, up to the topic, and I can imagine very, very few things which would have been done better than this. For me, this was excellent, and there was example how the review should look like. But we had local points as well.
So yeah, I'm between good cup and bad cup in one person. So actually, the reason why opposition got 6 from me and you got 5 is mainly because you really didn't distribute questions nicely. So you could have gained 2, but you were just okay relevant, but it's not suitably allotted, so that was only 0.5. On the other hand, I had to be consistent with this morning and myself. So the ones that I gave 7 and 6 were, I think, much better.
Just kind of on that, we of course will have different opinions.
Of course.
It's completely fine. Because for me, if it's so clear that there are many missing points in the presentation, I would personally also do that focus on clarifying that, and maybe have lesser questions for the opponent. So some jurors like that, some jurors doesn't like it. That's okay. But some more comments?
No, I could also add on the reviewer that, well, as I say, I more or less fully subscribe to the opinion that I think you fully clarified out. However, I would have liked to see a little more opinion from you on what, I mean, for example, the key 2 numbers here brought up is the Weber number and the Reynolds number. So it would have been more interesting to hear, okay, do you agree that, for example, the Weber number is an interesting number? Do you agree that the Reynolds number isn't it? So, I mean, so to say, the reporter made, I understand it was very quick, but they made a number of statements on what they think were things going on, and I would have liked to see a little more of that. But again, I think my 7 for me is, I mean, with over 5, it's a significantly higher mark. I liked a lot of what you did, and just continue that way.
Janet?
Yeah, and
Sorry.
I'm a non-voting juror, but maybe also a short feedback to the reviewer. So I really much liked how you understood the report and the opposition. I fully agree to all your explanations of both. But what I not liked was at the beginning your questions. So the first half was very great. Although it was a bit too centered maybe on the report, and maybe this could be seen in this way. But then you asked the opponent some questions, and I think they were quite irrelevant. So can you re-explain what the Weber number and Reynolds number is? This is okay, but it is not helping us to further understand the report because it was already explained during the report in a, I think, quite a good way. So if you use further this time to ask more relevant questions also to the opponent, you so it was in my case between.
Shouldn't say.
I shouldn't say, okay, so it was.
Thank you very much.
Did we all-
Yes.